6.6 Special Quadrilaterals. By the end of this lesson, you should be able to understand how you can use properties of quadrilaterals to identify special quadrilaterals. Taking a look at this next screen, we see our entire family tree of quadrilaterals that we learned about. We spent the first part of this chapter talking about parallelograms and special types of parallelograms like rectangles, rhombuses, and squares, and all their properties. Then this past weekend, we talked about kites and trapezoids. And we can use this and their properties to help us find out what type of quadrilateral we're looking at if we're just given specific given information. So let's say we were told that diagonals are congruent. Well, looking at this, we can see that diagonals are going to be congruent in a rectangle, and it's also going to be true for an isosceles trapezoid. So we can narrow it down to what type we're looking at. If we gave more information, like saying that it also had all right angles, then we can further say that it's going to be a rectangle. So this chart, if you haven't copied it down already, would be a good idea to do that right now and just pause the video. If you are ready, then go ahead and continue. Really, what we have is just some practice. Section 6.6 is just putting together what we've learned in the rest of this chapter to be able to identify quadrilaterals. And some of these are actually just easier to do than others because of how they look. So looking at these quadrilaterals, we're going to try to give the most specific name. For number 1, we see that it has all of its sides congruent, so it's an equilateral quadrilateral. We can always refer back to our chart from the previous page and take a look. Okay, well, if it's an equilateral quadrilateral, I know that's true for a rhombus, and that's pretty much it. So what we can say for this one is that this is going to have to be a rhombus. All right, for the second one, we see that we have a pair of opposite angles or opposite sides that are congruent, as well as the other pair of opposite sides that are congruent, and we also see that it has 4 right angles. Looking back here, kites have consecutive angles that are congruent, but no opposite angles are congruent, or sides rather. And isosceles trapezoids have a pair of opposite sides that are congruent, but that's it. So we're looking at a parallelogram based off of both opposite sides are congruent. But then, seeing that we can see that we have 4 right angles, that means that we're looking at a rectangle. And so for the second one, we can go ahead and say that that's a rectangle. Now the last one here has 1 pair of parallel sides, and then the other pair is congruent. Well, if we have 1 pair of parallel sides, we can't say that it's any type of parallelogram because both pairs have to be parallel. Kites, they don't have anything about parallel sides. We know that we're looking at a trapezoid. And the fact that we have a pair of congruent sides means that this is an isosceles trapezoid. So here we can say this is an isosceles trapezoid. Now, in all honesty, these look like the shapes that we're talking about, so it is a little bit easier to solve. So if they looked like something different, or if you weren't able to tell what they were, then you'd really have to focus on the properties that are given. And so let's do that here for questions 4 and 5. These same instructions, identify the quadrilateral and to give the most specific name. So looking at number 4, I see that, well, it's a quadrilateral. It looks like a square, but we can't go off of that. We're just going off the properties. And the properties that we see here is that I have diagonals, and those diagonals are bisecting opposite angles. So, looking back at our chart here, trying to find something that bisects opposite angles is what we're looking for. And we see that that's going to be true in a rhombus. So, we can say that this is a rhombus. The next one we see we have 1 pair of parallel sides, and then we have another pair of congruent sides. Now, since it only has 1 pair of parallel sides, we can't say it's a parallelogram, but we can say that it's a trapezoid. And seeing that it has a pair of congruent sides, we can say that it's an isosceles trapezoid. So for this one, we will say that this is an isosceles trapezoid. Now, look at the difference between number 5 and number 3. They were both isosceles trapezoids. They both had the same properties, but be prepared to use the properties when you're given shapes that look just like one another. And that really forces us to make sure that we understand and have memorized this whole family tree. So, as I've been reminding you in class, if we haven't done so, download the flashcards that are made on Quizlet, come see me for note cards, do whatever it takes for you to have these properties down. And that really is all that this last section is about. We have one more tomorrow, which is about areas of all our quadrilaterals, but this is it for today. We'll practice more tomorrow. And we are ready for our joke. So what do you call Santa when he stops moving? Well, you call him Santa Claus.